Today's purpose, as we look at congruent figures, is to be able to recognize congruent figures and their corresponding parts. So, two polygons are congruent if they are the same size and shape, meaning their corresponding angles and sides are equal. So looking here, definition of a corresponding figures or corresponding polygons, which means a many-sided figure. They have congruent corresponding parts. They're matching sides and angles. So notice this is color-coded. So AB, so if you printed this in black and white, you're going to probably want to highlight. AD is congruent to EF, and AB is congruent to FE or EF, and BC is congruent to FG, and DC is congruent to GH. And notice how all of these are marked and indicated that way here. The angles are also congruent. That if they are congruent figures, the angles are also congruent. So the colors match. So where the pink and the yellow line up, B and F are congruent. Where the yellow and the orange line up, C and G are congruent. Where the orange and the green line up, D and H are congruent. And where the pink and the green line up, A and E are congruent. So that's how you're going to make sure that you've got the corresponding pieces so you match them up correctly. The other way to know that they're corresponding is they match up based on how the triangles are written in congruency. So notice up here that they say A, B, C, D is congruent to E, F, G, H. That means angle A and angle F are congruent. Angle B and angle angle A and angle E are congruent. Angle B and angle F are congruent. Angle C and angle G are congruent. Angle D and angle H are congruent, which is what they show you down here. So the way that they write it is how you identify the corresponding pieces, unless that you're using the picture. So looking at this next part of our problem, we have that we're going to find the congruent parts here. We're going to list 3 pairs of sides and corresponding pieces. So again, I'm going to mark them the way that it's marked up here. So CA is the first piece. So I'm going to mark CA. This segment right here is congruent to JS. So I'm going to mark JS as congruent. And then AT, which is the next set right there, and SD are congruent. So JAT, 2 lines, and SD gets 2 lines. And then that means the third side is congruent. I'll just give that one 3 lines. So determining which angles are congruent, they should match up, right? So C is congruent to J. So I have the 3 lines and the 2 lines. So C and J are congruent. And then I have A and S are congruent. Notice this is from the way that the letters are written. So D and T are congruent. So D and T are congruent. So to write out the pairs of corresponding parts and everything, you're going to do the 3 pairs of corresponding sides. You have AC is congruent to JS or SJ. And you have AT. Make sure you put the line over there so you're talking about the segment, is congruent to DS. And segment CT is congruent to segment DJ. And again, the lines over the top mean I'm talking about the segments and not the measures of the segments or the sides. There's 3 angle congruents that are congruent to each other, the 3 pairs. I have angle A as congruent to angle S. I have angle C is congruent to angle J. And then I have angle T is congruent to angle D. Sorry, I got lost in my picture. Okay, so if you go down here and you do this one, pause the video and mark it up. Did you mark it like this and get those shapes If not, pause and correct it. Make sure that you have W and S, angles W and S are congruent, angle Z and M are congruent, angle Y and L are congruent, angle X and angle K are congruent, and then the sides that match that. Make sure everything's congruent, or matching. Okay, the next part we're going to talk about is that the theorem that we're going to talk about next follows from the triangle angle sum theorem, which says that all the triangles inside a triangle are added up to 180 degrees, right? So this one says that if two of the angles inside of a triangle are congruent to two angles in another triangle, then that third angle has to be congruent. Pair has to be congruent as well. So if A and D are congruent and B and E are congruent, then C has to be congruent to F. That's what the third angle theorem states. So we're going to determine if two triangles are congruent. To determine if they are congruent, we have to make sure that we have 3 pairs of congruent sides and 3 pairs of congruent corresponding angles. All right? So 3 pairs of congruent sides and 3 pairs of congruent angles. So looking here at this first figure, I have to check, do I have corresponding congruent sides and angles? So let's start with the sides. Well, this says that GH is congruent, so these are congruent because it's given. These are congruent because it's given. And is the third side congruent? Yes, it is, because it's a reflective property. That side is congruent to itself. So I have the 3 sides, so I've met the 3 side part. So then the question is, are the 3 angles congruent? Well, these angles right here, I and G are congruent because it's given. And angle GJH and angle HJI are congruent because they're both right angles. And all right angles are congruent. And therefore, the third angle is congruent based on my third angle theorem. So yes, this one is congruent. Now take a second and look at this one. Pause. Determine if it's congruent or not. I'm going to say no, it's not congruent, because though the angles work, like this is vertical angles, and these two are 90 degrees, 95 degrees, that makes this one congruent to that one, right, by our third angle theorem. Those are going to be congruent. But nothing tells me that the side lengths are congruent. There's nothing to indicate which sides are what. So this one I cannot prove congruent. Okay, looking at my next one. So I have the sides here. So all of the sides are going to have to be congruent, right? So I have these sides are congruent. This is congruent to itself. I have no idea if this one is congruent or these are congruent. I don't know. I also don't know if this is a right angle. I mean, I know this one is, right? I have one right angle. But then the opposite side, angle A, how do I know angle A is congruent? I don't know. So I have to say that this is a no. I cannot prove that. Looking at this one, give it a try. You should get yes. Why should you get yes? Well, the sides are all marked, right? So these sides are congruent, these sides are congruent, these sides are congruent. So the sides are marked. I've got 3 pairs of congruent sides. How come the angles work? Well, these are vertical angles, so they're congruent, right, because they're vertical. And then these are parallel lines. Notice the arrows on them. They are parallel lines cut by a transversal, which makes these alternate interior angles. And these alternate interior angles. So angle G is congruent to angle K, and angle F is congruent to angle J. And because of that, I have 3 pairs of angles that work and 3 pairs of sides that work. So yes, this one is congruent. Okay, looking at this one, I'm going to use the fact that these are congruent shapes to figure out what the size is. So notice that this is 74 degrees, which makes this one 74 degrees. These are both 5x, and that's 3x plus 2. So if I want to find out what x is, I just use my triangle sum theorem, right? Everything adds up in a triangle to 180 degrees. So I have the 5x plus 3x plus 2 plus 74 equals 180. And then I just solve that. So that's going to give me 8x plus 76 equals 180. And my justification for that was combining like terms. Then I'm going to subtract 76. So that's going to give me 104, and then I'm going to divide by 8. So x is actually 13. Okay, you pause and do this one. You should have got that x is equal to 5. If not, ask me about it when you see me. All right, the next piece of information is here. We're going to look at some more congruent figures. I'm going to tell you one of the best things to do when you're trying to prove something is draw it, and draw it so that you can see what you need to see. So A, B, C, D is congruent to F, G, H, J. So I'm looking at a quadrilateral. It doesn't matter what kind of quadrilateral I draw, but I'm going to draw it and mark it so that I already, whoops, that should be a straight line. So I already have it, the corresponding pieces together. So this is A, this is B, this is C, this is D. So then this is going to be F, G, H, and J. And my sides that correspond, AB corresponds with FG, BC corresponds with GH. Again, I'm marking it according to how this is labeled. Then I have CD is corresponding to HJ, or JH, however you want to write it. And that leaves me with AD is corresponding and congruent. All these pieces are congruent because the shapes are congruent, which means all the angles, the green and pink, where they match are congruent, and so forth. So with that information, I look over here to this problem. I'm going to find the measure of the given angles or the lengths of the given sides. So measure of angle B, that's this one, and angle G, okay, these two are corresponding congruent pieces. So I'm just going to write my equation, 3y equals y plus 50. So then I'm going to get 2y equals 50. And that's going to give me that y is 25. And when I substitute it back up in here, I'm going to have 3 times 25 is 75. So 75 degrees is the measure of both angles B and G. So then here I have sides, this, without the line over them, remember this is the measure of the side. So the measure of side CD is 2x plus 3, and the measure of side of HJ is 3x plus 2. Notice those are congruent pieces according to my labeling. So then I have 2x plus 3 equals 3x plus 2. I'm going to solve that. I'm going to get 3 equals x plus 2, so x equals 1. Then I substitute that back in. This gives me that 5, sorry, not 5 degrees. The length is 5. All right, you do this one and that one and come back to me. You should have gotten the 70 degrees as your angle measures and 14 as your side lengths. All right, look at this one right here. I want to do this problem. The one thing that we're missing information-wise is that a quadrilateral has 360 degrees as it's some of its interior angles. So you would set this one up, and you would have all of these are different angles. So this one right here and this one right here match. This one right here and this one right here match. Whoops, I'm sorry. This one and this one match, S and the X degrees. So notice I have all of my degrees here. So it'd be 45 degrees plus 3x plus that's X because they correspond and congruent. And this is 5x. And that's going to all equal 360. When you do the math to solve it, you're going to find out that X is 35. All right, getting to the proof. What do you do with the proof? Okay, so I want to prove that the triangle ADB is congruent to the triangle CDB. And the information they give me is my picture and my two statements. So starting with my givens, as always, I'm going to write that BD is the angle bisector of angle ABC. And I'm going to write BD is the perpendicular bisector of segment AC. And this is 1 and 2, and these are both given. Then my next step is going to be, okay, well, to prove that the triangles are congruent, I have to prove that all of the angles are congruent and all of the sides are congruent. So since I'm starting here with this bisector here, I'm going to start by noting all of the sides. I'm sorry, all of the angles. Let's do the angles first. So angle ABD is congruent to DBC. Angle ADB, ABD is congruent to angle DBC. This top angle is congruent to the other top angle, this one right here. Why? Because that's the definition of angle bisector. Right? It cuts the angles in half. They're equal to each other. Then step 4, I'm going to say that angle A is equal to angle C. Why can I say that? I'm sorry, congruent. I can say that because it's given in my picture. Then number 5, I'm going to say that angle ADB and angle ADC are right angles. They're right angles. That's the definition of perpendicular. Then I'm going to say that angle ADB is congruent to angle ADC because all right triangles are congruent. That was one of our theorems. Then, next step, I've done all of my angles, right? So now I'm going to do all my sides. So they give me that AB and BC are congruent. That's given. And then they give me, then I know that BD, right here, is congruent to BD because it is itself. That's step 8. And that's the reflexive property, right? Anything is equal to itself. Then step 9, I'm going to say that AD is congruent to BC because, by definition of bisector, which they told me, right? They said BD was a bisector. Then 10, I'm going to state that ADB, triangle ADB, is congruent to triangle CDB because definition of congruent figures. So if you have any questions, let me know, and I'll see you when I see you.